This video is an exploration of Newton's first three laws. It will also provide several methods of defending yourself against lone attacks by water bottles intent on doing you harm. Newton's first law, a body at rest stays at rest unless acted upon a force, will be demonstrated in several ways. Bodies at rest, we have the projectile, the shooter, and the bottle. All three will be affected by a force. The second law, force equals mass times acceleration. We will be using different masses and different acceleration forces and noting the difference in effect of those two. The third law, every action there is an equal and opposite reaction. In our case, as the gases expand, propel the bullet forward, the shooter's shoulder is propelled backwards, and downrange, when the bullet impacts the target and two bodies try to occupy the same space at the same time, you will see the results. Now, physics should be fun, so let's head out to the range and see what we can do. While we were preparing our experiment, we were attacked by killer water bottles, one at a time. So first, we'll start with a small mass and a small acceleration force. A .22 long rifle, 42 grain cartridge at 1,040 feet per second. You'll notice that the action, projectile moving forward, causes a reaction to the rifle and the shooter. Small action, small reaction. You'll see the rifle barely moves back and up. On the other end of the equation, we have a small mass and a small acceleration, and you'll see the effects on the target. One killer water bottle defeated. So undeterred by this small reaction, the water bottles keep coming. So we'll move to a medium mass and a large acceleration force. A 7.62 mm by 39 mm projectile at 2,000 feet per second. This will move the rifle and the shooter backward. Medium action, medium reaction. So now we'll see the effect of a medium mass and a large acceleration. And you'll see much more graphic motion backwards and up as the shooter gives way. On the other end of the equation, we have a medium reaction to the medium mass and a large acceleration. And here we have some pictures that capture the reaction. One more water bottle defeated. Now we'll move to a large mass and a large acceleration force. This is a 4570 325 grain projectile at 2,000 feet per second. We have a large action and a large reaction from both the shooter and the water bottle. And here you'll note moving back and up over 6 inches. And we'll see the reaction on the water bottle. And there it is in slow motion. Here we have a couple of stills that captured that. And we'll also see the effect of two objects trying to occupy the same space at the same time. Not only did the water bottle blow up, but it blew down into the cardboard table. Finally, we'll end up with a large mass and a medium acceleration force. This is a 12-gauge shotgun slug, 437 grains at 1,080 feet per second. Large action, large reaction, both on the shooter and the target. Here you can see, as the projectile moves downrange, a large reaction, almost 8 inches of backward pressure on the shooter. And we'll have a similar reaction on our target, the killer water bottle. Target was pretty much vaporized. Now you see it, now you don't, thus ending the attack of the killer water bottles. So our experiment showed that a large mass with a medium acceleration produced the most reaction both on the shooter and downrange.